Hi, and welcome back to Unit 3 of our course, From Media Computation to Data Science. In this video, I'd like to show you physical computing, but not the kind of physical computing that you might expect. Actually, we're again going to look at things that come out of the microphone, kind of taking it into a different context. Let's explore the microphone block again and check out the options. In the microphone block, we've already seen the volume and we've already seen the frequency. But there's more. Check out the samples. Now if I click on the samples, what I'm getting is a list. A list of numbers in between -1 and +1, and some of them are actually 0. The samples are the raw data that my microphone records. And what they stand for is the membrane in the microphone going to one side and the other side, kind of the percentage of where the membrane goes to. So if this is what the microphone is recording, it would be fun to look at this some more to analyze what it does. Now, since this is just a list, we should be able to use some list blocks on it. We go to the variables category. You remember, here's a block that we use to enumerate the elements of a list, as the for each block. So we can go and for each item in those microphone samples, do something with them. And what we want to do is, we would like to draw them onto the stage, not as colors, but in a diagram, in a coordinate system. So let's draw something. We're going to put the pen down. Once we're done, we're going to lift it up. We're also going to clear something before. And we're going to start at a position at the left of the stage. And we have a block for that. The off block, we can select the stage and we can select left. And we put that into the X position. And we're going to leave the Y position at 0, putting it into the middle. And now, let's look again at this list. This list is 512 items long. And this number, it's kind of the size of the list. We can also get it from the resolution. That is the length of the list that we get from the microphone. And that can vary from microphone to microphone and from computer to computer. So here, our length is 512. So when we draw those samples, we want to move the sprite over and draw something, and always move a tiny bit to draw the next one. So we want to find out how much to move. We're going to call this the slice. And the slice is going to be the amount we're moving is going to be the width of the stage divided by the resolution of the microphone. The microphone resolution and the width of the stage. So we're setting the sprite to the left, and now for every of these samples, we're going to go to where the sprite was, which is its X position, plus one of these slices, and the Y position is going to be the size of our samples. Now we've seen that the samples are in between -1 and +1, so if we're just plotting that, we're not going to see much. So we need to augment that and multiply it by, let's say, 160 to make use of of our whole stage. So it's the item plus 160. And we want to do this all the time. Go back and plot it. And we want to do this very fast. And remember, doing something fast is the warp block. So we again put the warp block in the middle of this forever block. Let's give it a try. So we see we're plotting the samples. And as I speak, you see it's kind of like an oscilloscope, and you can see the waves as I'm talking. You can already also see there's a sprite still here. And if that bothers you, we can go to the looks category and take out the hide block and hide it. And we've just built ourselves an oscilloscope. And now we can already try interesting things. You can see my voice. You can also hear me whistling. And you can see the wavelength kind of change as my tone changes. Well, we can try things like a harmonica. See how the waves are slightly different than to say a pan flute. Or a ukulele. And you can also see as the ukulele fades, the waves get flatter. Isn't that cool? We've just built ourselves an oscilloscope in which you can go out and examine the world. But wait, there's more. Let's stop this. And if you look at the microphone block again, there is one more option that is also fun to explore. There is also something called the spectrum. Now, if we look at the spectrum, it's another list, 512 items. There are also numbers in there, but the numbers are bigger. The numbers are in between 0 and 255. And what the spectrum really is it analyzes the nature of the sound. It checks which frequencies the sound is made of and how strong these frequencies are. Now, since it's the same length of the list, we can almost use the same script to look at these spectrums. So I'm going to duplicate this script, and I'm going to leave everything as it is, but I'm going to enumerate not the samples, but the spectrum. Now, because the bins in the spectrum, the items of the spectrum, range from 0 to 255, I don't want to multiply it by 160, but I'd rather want to subtract 160 from it and kind of move the curve down towards the bottom, and also want to start out at a minus 160. Now we're going to try the second script. I'm going to run this and watch what happens. We now have a spectrum analyzer that analyzes kind of which frequencies my voice is made of. Now, all to the left is where we hear best, and roughly at not even the middle of the stage, we're not hearing these frequencies anymore. But the tone of our sounds are made of many things and of many frequencies that go even beyond from what we can hear. So, for example, let me take again this ukulele and kind of see what this is made of. And you can see it's mostly always to the left. If I go to a very high tone, you can see there are more spikes in there. I take my harmonica. You can see distinct spikes. It's a very clean sound made of very distinct spikes. And this is something that is very interesting for you to check out the voice, check out how, for example, a male voice is different from a female voice, or a child's voice is different from an adult. For your project, we'd like you to experiment some more with the frequency. Now here, we're just mapping the frequencies along an x-axis. Now if you combine this idea with the color idea we've been speaking of, you can make something that looks like, let me show you. I'm going to show you this project. This is your project. I'm not going to show you how it's done, just what it does. I'm going to turn this on, and this draws kind of like a heat map of what I'm speaking. And you can see my voice as I'm saying something. You can see kind of on the vertical axis, these are the overtones, and you can see, you cannot see certain tones, but watch me whistle. Or I can sing, Mary had a little lamb, little lamb, little lamb. And you can see the tones here. And tell you what, I'm now begging on stage a very special guest. Ladies and gentlemen, welcome our chief trumpeter, Yadga.
Oh my God.
Yay! Have fun with this at home. Your neighbors will love your experiments, and see you in the next unit.